A security flaw hidden inside Linux for 15 years sounds like the plot of a technology thriller. But in 2026, that is exactly what happened. An AI-powered security tool uncovered a vulnerability that had been sitting quietly in the Linux kernel since 2011. For more than a decade, thousands of developers, researchers, security experts, and companies worked on Linux code every single day. Yet somehow, this bug survived. It wasn't discovered by a human researcher manually reading code. It was found by artificial intelligence. And that raises a much bigger question than the bug itself. If AI can find security flaws that humans missed for 15 years, what else is still hiding inside the software that powers the modern world? The vulnerability, known as GhostLock and tracked as CVE 2026434499, was discovered by security researchers using an AI-powered bug hunting platform called VEGA. According to reports, the flaw existed in Linux kernels dating back to version 2.6.39 released in 2011. The vulnerability allowed a local user to gain root privileges on affected systems, effectively giving them complete control over a machine. Security researchers described it as one of the most significant Linux privilege escalation vulnerabilities discovered in recent years. To understand why this discovery matters, you first need to understand what root access means. In Linux, root is the highest level of privilege available. A user with root access can install software, modify system files, create accounts, remove security controls, and essentially do anything they want. If an attacker gains root access, the entire security model of the operating system can collapse. That is why vulnerabilities that lead to privilege escalation are considered extremely dangerous. What makes GhostLock even more surprising is how long it remained hidden. The Linux kernel is one of the most heavily reviewed software projects on Earth. Thousands of developers contribute code, and millions of servers, cloud systems, and devices depend on it every day. Many people assume that open-source software is constantly examined by experts, making it difficult for serious bugs to survive for years. Yet, this vulnerability sat inside the kernel for approximately 15 years before being identified. The discovery immediately sparked conversations throughout the technology industry. For decades, Linux has built a reputation as one of the most secure operating systems available. It powers the majority of cloud infrastructure, most supercomputers, countless enterprise servers, and billions of Android devices through the Linux kernel. Many organizations trust Linux precisely because of its security track record. So when a 15-year-old root vulnerability suddenly appears, people naturally start asking whether Linux is still secure. The answer is more complicated than many headlines suggest. Finding a vulnerability does not automatically mean an operating system is insecure. In fact, discovering and fixing vulnerabilities is a normal part of software development. Every major operating system contains bugs. Windows has them. Mac OS has them. Android has them. Even highly specialized enterprise systems contain security flaws. The real question is how quickly vulnerabilities are discovered, disclosed, patched, and distributed to users. What makes this story different is the role artificial intelligence played in the discovery process. For years, security researchers have used automated tools to scan software for weaknesses. AI is now taking that capability to an entirely new level. Instead of looking for a handful of predefined patterns, modern AI systems can analyze enormous codebases, identify unusual behaviors, and uncover vulnerabilities that might otherwise remain hidden. Researchers increasingly believe that AI could transform cybersecurity in much the same way automation transformed manufacturing. The GhostLock discovery appears to support that idea. Reports indicate that the AI system analyzed old kernel code and identified a use-after-free vulnerability. In simple terms, the kernel continued referencing memory that had already been released. Under the right conditions, that mistake could be exploited to gain elevated privileges. While the technical details are complex, the important point is that the vulnerability existed in code that had been reviewed countless times by humans. This isn't the only example of AI influencing Linux security. Throughout 2026, multiple vulnerabilities have been discovered using AI-assisted techniques. Security researchers are increasingly deploying automated systems capable of examining millions of lines of code much faster than human teams. As these tools improve, they are uncovering flaws that traditional auditing methods failed to detect. Ironically, the success of AI bug hunting has created new challenges for Linux maintainers. Linus Torvalds recently criticized the flood of AI-generated vulnerability reports, overwhelming Linux security channels. Multiple researchers often discover the same issues simultaneously using similar AI systems, creating duplicate reports and increasing the workload for maintainers. Instead of reducing effort, AI sometimes generates so many findings that developers struggle to process them efficiently. For Linux users, the immediate concern is whether they should panic. The good news is that Ghostlock was patched after its discovery. Like most privilege escalation vulnerabilities, exploitation requires some level of access to the target system. It is not the same as a remote attack that allows someone across the internet to instantly compromise a machine. However, in environments where attackers already have limited access, such vulnerabilities can be extremely valuable because they allow escalation to full administrative control. The broader lesson is perhaps more important than the bug itself. Many people think cybersecurity is about building perfect software. In reality, perfect software does not exist. Modern operating systems contain tens of millions of lines of code. As complexity increases, hidden vulnerabilities become inevitable. Security is not achieved by eliminating every bug. It is achieved by finding bugs faster than attackers can exploit them. This is where AI may completely reshape the future of cybersecurity. For decades, defenders and attackers operated at roughly similar speeds. Human researchers found vulnerabilities. Human attackers exploited them. Human developers created patches. Artificial intelligence changes that balance. AI can analyze codebases at a scale impossible for human teams. It can identify patterns, compare implementations, and uncover weaknesses much faster than traditional methods. That creates both opportunities and risks. On one hand, defenders can use AI to discover vulnerabilities before criminals do. On the other hand, attackers can use similar tools to find weaknesses and develop exploits. Some cybersecurity experts worry that AI could dramatically reduce the time between vulnerability discovery and exploitation. The future may involve a constant race between defensive AI systems and offensive AI systems competing to find software weaknesses first. Linux itself is likely to benefit from this trend. Open-source projects have a unique advantage because their code is publicly available. Researchers, companies, universities, and independent developers can all examine the same code base using increasingly advanced tools. As AI-powered analysis becomes more common, vulnerabilities that previously remained hidden for years may be discovered much earlier. That means future Linux releases could actually become more secure, not less secure. The discovery of Ghostlock also highlights one of the greatest strengths of open-source software. When a vulnerability is found, the community can inspect the issue, verify the fix, and distribute patches openly. The process is transparent. Researchers can examine what happened, learn from the mistake, and improve future development practices. While vulnerabilities are inevitable, transparency helps the ecosystem respond quickly and build stronger defenses over time. Another reason this story matters is because Linux powers so much of the digital world. Most people think of Linux as a desktop operating system used by programmers. In reality, Linux runs much of the internet. It powers cloud platforms, web servers, enterprise infrastructure, networking equipment, embedded systems, and Android devices. A vulnerability in the Linux kernel has implications far beyond desktop computers. That is why discoveries like Ghostlock attract so much attention from security professionals worldwide. Yet, despite the dramatic headlines, Linux remains one of the most trusted operating systems on the planet. The discovery of a 15-year-old vulnerability does not erase decades of successful deployments across governments, enterprises, research institutions, and cloud providers. If anything, it demonstrates that the security community continues improving its ability to find and fix problems before they become widespread threats. Perhaps the most fascinating part of this story is what it reveals about the future. 15 years ago, nobody imagined an artificial intelligence system would someday uncover a vulnerability hidden deep inside the Linux kernel. Today, that future has arrived. AI is no longer just generating text and images. It is becoming an active participant in cybersecurity research. The tools are getting smarter, faster, and more capable every year. So is Linux still secure? The evidence suggests yes. But the definition of security is changing. Security is no longer about believing software is flawless. It is about continuously finding weaknesses, fixing them, and adapting faster than emerging threats. The discovery of Ghostlock reminds us that vulnerabilities can hide for years, even inside the world's most trusted software. At the same time, it proves that new technologies like AI are giving defenders powerful new tools to uncover those hidden risks. The bug may have remained invisible for 15 years, but its discovery could mark the beginning of a new era in cybersecurity, one where artificial intelligence helps secure the digital world in ways humans alone never could.